Hello everyone, welcome to Reactify Labs. Today we will talk about event-driven architecture. Event-driven architecture. And as the name suggests, there will be some kind of architecture which will be driven by an event. Means some event happens and it will trigger something, right? So just to explain it quickly using some kind of analogy, I would say let's take an example of when HR announces that, let's say, there is a pizza party in office. Hmm? So it's not only true for office. Like let's say in your university also there is some coordinator, maybe director or somebody sent the email that there will be a pizza party. In the school also these kinds of things happen, right? Let's say there is a pizza party. So this is an event, right? The announcement of pizza party is an event. Okay. So what happens with this event? As a result of this event, this triggers something. This triggers what? Excitement. Hmm? And people move to cafeteria. Right? Cafeteria. So this is what happened here. This event drove the people to cafeteria. Similarly, in systems, what happens is some events trigger some things, right? Some events trigger some things. So that's what event driven architecture is. There are actually two more things here. The person who announced it, for example, here in that case, HR. This HR will be called event producer who produced the event. And this people who are consuming the event, right? They are consumers. Hmm? And let's say this HR introduced this or announced this thing using an email or a group message or a broadcast message. So this is basically an event broker. So these are the four primary components in event driven architecture: event producer, event consumer, event broker, and event itself. Okay. So I hope this gives you a good understanding and good base to start the event driven architecture and to expect, not expect, and to give a clear idea of what to expect in the further discussions that I'm going to do now. Okay. So now that we have clarified the requirements, not requirements actually, it's more like clarified the basics. Now we can relate it with our daily life. So now let's start with the technicalities of it. Okay, so the structure that we are going to follow today is, first we will start with the introduction. Okay. Next, we will move to see what are the core concepts involved in the event driven architecture. Okay. After that, we will see the technical details of it. Technical details. After that, we will move to see the implementation details. Implementation details. Then we will see what are the advantages of using the event driven architecture. And lastly, we will talk about the challenges associated with this architecture. Okay. So yeah, let's start with the introduction. Event driven architecture is a design paradigm. It's a design paradigm in which the flow of data is driven by events. Okay. In which the flow of data is driven by events. So events are, what are events? Events are significant changes in the state of a system or an external environment that are captured and acted upon asynchronously. Event driven architecture enables systems to be highly decoupled, scalable, and responsive. Okay. So let's see what are the core concepts involved in the event driven architecture. As I told you before, there are four basic things: events, event producers, event producers, event consumers, event brokers. There are two additional things. One is event channels, hmm, and event streams. Okay. So good thing is they all start with event, so easy to remember. And there are six core concepts involved in event driven architecture. So let's start with events. What are events? An event represents a significant change in the state of an application or an external system. It encapsulates information about the occurrence, such as data and metadata. Examples would be like the user interactions. For example, a user places an order, or let's say a system changes. Okay, a file gets uploaded, or some external trigger like you received an email. Okay, so this is the event. And let's say you placed an order. So what happens when you place an order? When you place an order, you get a notification that yes, your order was successful, and you get a message that your order was successful. So this is event driven architecture. As soon as the system received an event that order was placed, it triggered the email, right? So that's what it is. Next, event producers. Okay, let's talk about event producers now. So event producers generate events and publish them to an event broker or directly to the parties which are interested in that. Producers are responsible for creating and sending events when a state change occurs. Okay. So, for example, in a retail system, an order service that creates an order and generates an order created event is an event producer. Okay. So the system which generated the order is the producer of the event. Okay. Next, let's talk about event consumers. So event consumers are just the opposite of producers. Producers produce the event, consumers consume the event. So event consumers listen for and processes the event. They act upon the events received to perform specific tasks or update their state. Okay. So again, taking the example of the retail system, an inventory service that updates stock levels based on the order created event is an event consumer. Like let's say there is a phone and somebody placed an order for the phone, right? So the service which placed the order, like placing the order was the event, right? The service which helped in placing the order was the producer, and there will be a consumer like inventory. So this consumer, what it will do, it will reduce the stock count, minus minus. Okay, stock minus minus. So this is the job of the consumer. So depending on the event, the consumer got triggered and it will do something. Okay. Now let's see the event brokers. Event brokers facilitate the communication between event producers and event consumers. They manage event distribution, routing, and sometimes persistence. Like there should be a way, right, for the event producer to talk to event consumer, because the system is decoupled. Producer and consumer are not at the same place, right? Or they are not tightly coupled. It's not in the same system. So we need a broker to communicate. So examples of event brokers include Apache Kafka, RabbitMQ, right? Okay. Next is event channels. So these four were discussed before as well in the analogy. So I believe it would be easy for you to relate. Now let's see these two new things: event channels. So event channels are communication paths through which events are transmitted from producers to consumers. They can be implemented using messaging queues or publish subscribe patterns. Channels in Apache Kafka are called topics, while RabbitMQ uses exchanges and queues. Okay. And next is event streams. So event streams are continuous flow of events that can be processed in real time. They enable real-time analytics and processing. A stream of a real-time user activity logs processed to generate analytics, or a stream of transaction events for fraud detection. This is an example. Okay. So actually, if we have to understand this event channels and event streams again using some real life analogy, so we can understand it using this. Let's say your office or school or college has a newsletter. Okay, so event channel is kind of a newsletter. Each newsletter focuses on a specific topic, like let's say latest tech, latest in AI, latest in what's happening in behavioral, right? In school, if you see latest in club activities, sports events. So this is a real life example of event channels. And again, similarly, if we talk about event streams, so it's like a series of continuous announcements which are made throughout the day. Let's say in office, if you have this, like, okay, in breakfast we have this menu, in lunch we have this menu, or daily the lunch menu changes. So this is kind of like event streaming. Okay, event streams, example of event streams. So basically, event streams are continuous flow of events, as I said before, that can be processed in real time. They enable real time analytics and processing. For example, a stream of real time user activity logs processed to generate analytics, or stream of transaction events for fraud detection. Okay. Now, let's see the technical details. Technical details. So, first is event format. Events typically have a standard format that includes a header, metadata such as event type, timestamp, and unique identifier, and a body. Body is payload with event specific data. Events may evolve over time, requiring versioning or schema management to ensure compatibility between producers and consumers. Okay. Next is event processing models. Event processing models. So basically, it's like some simple event processing. Okay, so they process events as they arrive and perform immediate actions based on the event data. Okay, and what are complex event processing? Complex event processing analyzes patterns and correlations among multiple events to derive higher level insights or trigger actions based on complex rules. Okay, next is event storage and durability. So events may be stored in an event store for durability, replay, or auditing. Event stores ensure that events are not lost and can be replayed if needed. For example, Apache Kafka and Amazon Kinesis provide durable storage of event streams. Okay. Next is event sourcing. Event sourcing involves storing the state of an application as a sequence of events instead of storing the current state. Instead of storing the current state, all changes, like all the events, are logged, and the current state is derived by replaying these events. Okay, so the benefits of this is it enables easy reconstruction of state, auditing, and time travel capabilities also. Okay, and event driven communication patterns. Event driven communication patterns. So producers publish events to a topic or a channel, and consumers subscribe to these channels to receive events. Okay. So producers send events directly to a specific consumer or a queue where consumers can pick up events. Okay. So effectively, event driven patterns are basically pub sub model, publish subscribe. Somebody publishes, somebody subscribes. Okay. Um, so yeah, producers send events directly to a specific consumer or a queue where consumers can pick up the events. Let's talk about the implementation details now. Implementation details. So first is event brokers. Um, let's talk about Apache Kafka here. So, Apache Kafka is a distributed streaming platform that provides high throughput, low latency event streaming and durable storage. So, Kafka topics are divided into partitions to parallelize processing and ensure scalability. Kafka uses offsets to keep track of the position of consumers within partitions. If I'm not wrong, I think I have talked about Apache Kafka in the message broker video also. So yeah, I'm not sure. So that's why I'm covering it on a very high level. I'll go and check if I have covered it in detail or not. If not, then I'll make separate videos on Kafka, RabbitMQs as well. Okay. So next is RabbitMQ. So it's a message broker that supports various messaging patterns, including publish, subscribe, and point to point. So they route, like RabbitMQ routes messages to one or more queues based on routing rules, and it holds messages until they are consumed by the consumers. Okay. Next is event schema management. Event schema management. So, a schema registry manages event schemas, ensuring that producers and consumers agree on the format of events. Techniques such as backward compatibility or versioning ensure that changes to event schemas do not break existing consumers. Okay. And next is event processing frameworks. Event processing frameworks. So, a stream processing framework that provides real time analytics and complex event processing capabilities is Apache Flink. Similarly, Apache Storm is another real time computation system for processing stream of events. Okay. So, actually, if I go and talk about everything like Apache Flink, Apache Storm, and if I keep talking about every example that exists, this playlist will never end. So actually I don't even want this playlist to end. So I'll see. Let's see how much we can do. Okay. So let's talk about the advantages of event driven architecture. Because there are so many things, so many systems, they keep evolving. They every day new thing keeps coming, new technology keeps coming, old technology becomes obsolete, or old technologies evolve. It's a never ending thing, so we cannot always know everything. So it's better to know about one or two popular things, and then others, if they come in future, we know that okay, we had this basic knowledge and now we can continue from there. So obviously I'm not going to cover every system there exists in the universe, but yeah, I'll try to cover at least a few examples of each of those in detail. Okay. So what are the advantages? First one is scalability. Event driven architecture allows systems to scale independently by adding more producers, consumers, or event brokers. Next is decoupling. Producers and consumers are decoupled, enabling easier maintenance and flexibility in how components interact. Next is responsiveness. It supports real time processing and response to events, making it suitable for dynamic and interactive applications. And next is flexibility. It facilitates the integration of disparate systems and services through asynchronous communication. And now let's see the challenges associated with it. First one is complexity again, because the system is sophisticated, it has to be complex. Managing and coordinating events, ensuring schema compatibility, and handling errors can be complex. Event ordering. Ensuring the correct order of events and handling out of order or duplicate events can be challenging. Debugging. So troubleshooting issues in an event driven system requires like extensive logging, tracing and monitoring tools. So debugging and monitoring is another challenging task, and data consistency. Maintaining consistency across distributed systems can be challenging, particularly in systems with eventual consistency, right? So, yeah, that's all there was in the event driven architecture. I hope this video gave you a good idea about the event driven architecture. What are the advantages and challenges associated with it? What are the steps involved in an event driven architecture? What are the modules, and how you can relate it with real life? And if you know how to relate it with real life, you will never forget this concept. Okay. So, yeah, that's all there was. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.